welcome back to another episode of A2 Chemistry, and today we are doing transition element. So in this chapter we're going to cover a few important elements, which is the electronic configuration of transition element, at the same time the stability constant. Then what else? I'm looking at my notes. And also the drawing, so especially the drawing for your cis-trans and optical isomer, so you guys must know how to do it, as well as all the ligand exchange reaction. Okay, so these four things are very crucial. Please go through it at the same time. Just give me a minute. At the same time, you guys also need to know how to explain when a transition elements form a colored compound because of the d orbitals being split by your ligands into different degenerates that you need to know. So without further ado, okay, so let's go through the notes and go through the video. So we're going to cover from 0 to 100% of transition element. Trust me, this chapter itself is very important. Always come in your A2 exam, and weightage is about 10 to 20 marks easily for one question. So every single year you will be out in your P4. So it's a very important chapter. Please go through it. Yeah, have fun, guys. And spend an hour here and we get everything done and we move back to ionic equilibria. Okay, let's go. Okay, guys, stereoisomer in transition matter complexes. I finally brought over the model later. I will show you guys. But by the way, this section is very, very important here. Okay, so put some stars. Every single year, you definitely encounter one or two questions from here. Okay, so first, let's look at the geometric isomer. Guys, what is geometric isomerism again? Geometric isomerism is basically your cis-trans, right? Okay, so guys, for a cis-trans, okay, to be there for in a transition matter complex, the shape itself, right, must either be a square planar or octahedral. Okay, so it must be a square planar or octahedral. At the same time, right, it must have two different ligands. Okay, you must have two different ligands here. Okay, so for it to show a geometric isomerism. Okay, so that's for geometric. Okay, at the same time, we also have optical isomerism. Optical is what we have done earlier, is the mirror image one. So for mirror image one, right, must be an octahedral shape with a bidentate ligand. Okay, octahedral with a bidentate, yeah. Okay, the first structure that we have, right, geometrical isomerism. Okay, geometrical isomerism, right, must be in a planar complex, example, a square planar. Okay, so if you look at the general formula, right, you have a central matter ion connected to ligand 1, okay, 2 ligand 1 and 2 ligand 2. So basically you have two different ligands and the arrangement is always, okay, 2 ligand A, 2 ligand B. Okay, so you always have two different ligand. Example, guys. Okay, so you see ligand 1, ligand 2. I see that. All right, guys. Again, it must be in a planar complexes, which means this thingy cannot be in tetrahedral. It's never in tetrahedral. Okay, if it's in tetrahedral, it will not show a cis-trans. Okay, so example. Okay, so guys, we're gonna do the first arrangement like that. So if you can see, okay, my red color and red color, it's I'm gonna disable my blur my background. Okay, so red color is 180 degree apart. Can you see that? 100 degree apart. White color 180 degree apart. Okay, so again, similar ligand, 180 degree apart. That is the first arrangement. Okay, so guys, I can draw my PT in the middle. Okay, and let's draw a triangle. Let's draw a square planar. Alright, so the first one, right, I just have to put similar ligand NH3. 180 degree apart. Can see that, guys? 180 degree apart. Okay. Then another two more ligand, 180 degree apart. Can see that, guys? If you have a highlighter, you can take a highlighter. Do you see 180 degree? Do you see 180 degree? Can see that? So basically, this is the shape. Okay, 180 degree apart. All right, guys. Again, when you have a similar ligand standing at 180 degree apart. Okay, so again, it's opposite, right? When it's opposite in chemistry, right, we always call it as a trans. So this is a trans platinum. Okay, when it's 180 degree apart, we call it as trans. Okay, guys, or we can swap them. If you swap them right now, if you look at my structure, do you see that similar ligands are 90 degree apart? Okay, similar ligands 90 degree apart. Can see that 90 degree, 90 degree. Okay, so that's a cis. No matter how you rotate it, similar ligand is 90 degree apart. Okay, so this is the second. Okay, what's a platinum? A platinum is just another name for isomer, but for transition element. Okay, so a complex ion, the entire thingy, we just call it as a cis platinum. Okay, so guys, now when your similar ligand 90 degree apart. So guys, do you see it's a 90 degree here? Do you see it's a 90 degree here? Okay, so guys, when it's a 90 degree, okay, we call it as a cis. Okay, why? Do you see a C here? Can see a C. Okay, so guys, this is known as a cisplatin. Done. Understand? Okay, so guys, the first one is super easy. Clear? So guys, if you look at this, what I'm holding now, is this a cis or is this a trans? The cis, right? Can see, okay, next. This is a trans, right? Just look for 90 degree and 180 degree. Done. That's it. Simple as that. This is the simplest. Do not make any careless mistake. All right, guys. Again, sometimes in exam, okay, you have drawn something like that, but when you refer to the mark scheme will show you. Okay, so guys, are they the same? Is this another isomer? Oh my god. Yeah. Alright guys, what is this? It's a cis. So example, if you're drawing it right, you drew this, mark team show this, it's basically the same thing. Don't go and mark yourself wrong, say, "Chill, why is it different?" It's just the same. You just have to rotate it. Okay, you rotate it, summer already. Okay, it's just rotation. So guys, this is in 2D, two-dimensional. So you guys can visualize. Later we're gonna go into three-dimensional. Yeah. Okay, now guys, again, trans is always representing opposite, cis is representing together. Done. Next page. Okay, now it's gonna be a bit harder right now. Yeah, the CL can be replaced with anything. All right, guys, look at this model. What am I holding? What shape is this? Octahedral. Guys, still remember octahedral? What is the bond angle? for octahedral. Octahedral bond angle is always 90 degree. No matter how I rotate it, right, it's always 90 degree. Okay, later I'll pass this model around, then you guys can have a look. Okay, no matter how I rotate it, it's always forever in 90 degree. Okay, so guys, now let's say if you have a general formula, this is the general formula, guys. Again, this is not in the syllabus. This is how I summarize it for you. Okay, so again, central metal ion, I have one ligand, ligand A, 4 ligand A, 2 ligand B. Okay, so it's basically the same thing here. 4 white color, 2 red color. So guys, how do you arrange it? Let's look at the 2 red color. So guys, look at the red color now. Are they 90 degree or 180 degree now? 180 degree, right? Can see that? No matter how I turn it, flip. They are always in 180 degree, right? So guys, what you need to do, right? Just put 2 of the Y in 180 degree. Where you want to put it? I can put it here. I can put it here. Or I can also put it here, right? Up to you, right? Alright, so guys, I'm gonna put this region is the easiest to be identified. Can see that? Okay, so guys, remaining part, just put an X. Dun, 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 dun. So guys, do you see that your similar ligand is 180 degree apart, right? Am I right? So which means we call this as a trans bond. I'm going to pass this around. You guys go have a look. You can change it to a C for me. Go. Okay, so guys, okay, you can always, for example, right, you can always swap this to, we see right now it's 180 degree, right? You can see that 180 degree. What I need to do is just swap them to a 90 degree. You see that? Okay, I just have to swap them to a 90 degree. That will be a cis already. Okay, so remember, guys, how do you put it? You can put anywhere you like. Okay, so what I'm gonna do, I'm just gonna put it here and here. Do you see a 90 degree? Yes. And remaining, just put Cl X all the way. Done. Do you see that similar ligand 90 degree? Yes, huh? Can see, This is a cis arrangement. Easy. Clear. So guys, I'm gonna just randomly show you some funny shape. Please tell me what is this? Cis. Oh my god, cannot see. Like that. Cis or trans? Trans, right? Okay, again now, similar ligand, 180 degree apart. Trans. Okay, that's it. Look for the bond angle. 180 opposite is trans. Similar is cis. Again, guys, there's many ways of drawing it. Okay, guys, I'm just gonna show you some mark scheme answer, and I want you guys to tell me, is this a cis or a trans? No, fine. Now, guys, look at this structure and tell me, is this a cis or a trans? It's a cis. You guys can see that, right? 90 degree. Okay, again, there's many different way of drawing it. Okay, if you draw this and mark scheme show you this thingy, it's basically the same. Don't go and say, don't go and purposely copy. Some people memorize the shape by memorizing. Do not memorize the shape. Understand the shape. There's no way you can memorize. Please, don't memorize. Try to understand it. Alright, guys, this one done. Next, when you have another type, case 2, when you have A3, B3, okay, example, it does look something like okay. Okay, guys, this is a bit harder to visualize. So the first structure we have, right, let's look at the orange color. So guys, you see, right, the orange color, they are all arranged in a 90 degree, 90 degree. You see that? 90, oh, sorry, it's here. So one more time, guys, again, do you see 90 degree, 90 degree? Okay, and a 180 here. Okay, so you always have 290 and 180 here. Okay, so this first way of drawing it, okay, guys, I can put it like that. Okay, so this thing here that you guys are looking at, yeah, I'm just gonna put it here. Okay, so it's gonna be 2 at the side, 1 on top, right? So I put X here, X here, X here. Okay, maybe like that. You see, 2 side, okay, 1 top. Sorry, my bad, my bad, my bad. Wrong, 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 wrong. Like that, ha. Yeah, All right, guys, again, look at this structure, yeah. Okay, if I twist it just now, I was pointing it both sides facing you guys, right? Okay, guys, one orange facing towards you. Can see that? Another orange facing me. Another orange at the bottom. You have 180. Let's see. Do you see 180 here? Can see that? And a 90. One more time. Similar ligand. Do you see 180 degree? Okay, look at the white color. The white color, it's gonna be 180 degree as well. So I hope you guys can see the 180 degree. You can highlight this. That's a 180. You can highlight this. That's a 180. Okay, so guys, again, if your similar ligand is 180 apart, we call it as opposite, right? Okay, so that's a cis, but we don't call it as cis, or we don't call it as trans. We call it as fac or mer. A fac mer isomer is not in the syllabus. So I'm not so sure your school teacher mentioned fac mer. Naming wise, you don't need to care. So for this case, right, the naming, not in your syllabus. We don't call it as a cis trans. We call it as fac mer. But I'm not going to teach you guys because it's going to be very confusing. So let's assume that you don't know how to name it, because you do not need to know how to name it. Okay, but you need to know how to draw it. Drawing, yes, you need to know how to draw a different one. Naming wise, no. Alright guys, now I'm gonna swap them. Okay, so this is the second arrangement. Guys, if you look at this second arrangement, right, there's no way you can find 180, no matter how you twist it. There's no 180 degree. 90 degree, 90, 90, 90, 90, 90, 90. If I turn it, still 90, 90, 90. Turn, no matter how I turn it, it's always 90 degree. There is no 180 degree. Okay, so I'm going to pass it around, play around. Okay, so there's no 180 degree. So guys, let's put 390 degree together. So guys, 90 degree, 90 degree, 90 degree. Can see that? 90, 90, 90. Correct. Then 90, 90, 90. Done. Understand? So guys, this is 90 degree apart. This is 180 degree apart. You just need to know the bond angle. You just need to check the angle. Is it 90 or 180? And that's it. Done. Okay, simple as that. Clear? Easy out. Alright guys, I'm gonna randomly draw two shapes. Okay, and I want you guys to tell me, are they the same or they are isomer of one another? Alright guys, let's look at these two thingy. Are they the same or they are different? Yeah. Okay, you must be able to tell. Okay, because in the exam, right? Don't, so they are the same, right? Can see a 180. Can see a 180. Same. Okay, very simple. You just have to look for the straight line got straight line or no straight line. Simple as that. Don't memorize the shape. Do not memorize, go and must draw like that. No. When you twist around, the twist and turn around, it can be in many, many ways. Okay, so you just have to look for got straight line or no straight line. Done. Okay, now I'm going to just change one of them. Okay, are they the same or different now? They are different, right? Again, no straight line, right? You see, no straight line, okay, no straight line, right? So it goes like that, it goes like that. Can see that? So this is another isomer already done. Simple as that. Okay, easier. So basically we covered cis trans, we covered okay octahedral arrangement, we covered octahedral arrangement for A3B3. Okay, next optical isomerism. All right, guys, for optical isomerism, right, it must be first must have a bidentate. Remember, it must have a bidentate. If it's not a bidentate, it will never show an optical. Second, must be in octahedral. If it's not in octahedral, it will never show an optical. So must have bidentate and octahedral. Okay, so usually you will encounter something that has a bidentate ligand. Done. All right, guys, let's assume this is one of my bidentate ligand. Okay, so this one bidentate ligand. Okay, so guys, we can put the bidentate, you can put it anywhere. You just have to draw 3 bidentate ligand. Oh. Okay, so guys, I have 3 bidentate, as you can see. At the same time, octahedral, correct. Bidentate. Kid, what is bidentate again? Define bidentate. What is the definition of bidentate ligand? Oh, yeah, interesting, huh? Anyone? What's a bidentate ligand? It's a complex, it's an ion or molecule that has, yes, that can form 2 coordinate bond. Okay, remember, must be 2 coordinate bond using 2 lone pair, right? By donating 2 lone pair. Well done. Thank you, Hao Jie. Thank you so much. Okay, again, 2 coordinate bond using 2 lone pair. Okay. Okay, at the same time, kid, I have a question. What is my coordination number? Go. What's the coordination number here? Is it 3, 4, 5, 6? Which one? Coordination number is the number of dative covalent bond. So, okay. Okay. All right, guys, next. Okay, what if a substance with one of its, okay, again, let's look at your optical isomer, yeah? You can draw a mirror image right now. Okay, so let's draw a mirror image. So, kid, I'm gonna redraw. Wow. All right, guys, try draw a mirror image. Let's go. Put a mirror here. Okay, let's mirror it. How do you mirror it? So it's basically the same thing. So these two mirror like that now. All right. Okay, so guys, again, this is super easy. You just have to mirror it, and that's it. Okay, so I hope you can see the mirror here. And guys, you see, there's no way you can stack them. Let me try stacking them together. You see, can you stack them or not? You can't stack them. One more time. See, I'm trying to stack them. Boom. Look at it. Sorry, you cannot stack them at all. So which is why they are a mirror image. Okay, so you turn around. Wee. Okay, so again, you cannot stack them. That's it. Done. All right, guys. Next. Okay, an example of this complex, right? It's nickel as the transition metal ion. Okay, and with a 1,2 diamino ethane. So this NH2 CH2 CH2 as the bidentate ligand. All right, guys. I want you guys to draw, okay, the mirror image. I will show you how to draw the ligand. I'm just gonna show one. So maybe I'm gonna start from here. So it's connected to a NH2, connected to a CH2, connected to a CH2, connected back to a NH2, right? And then, all right, guys, go complete the diagram now. Okay, you just have to draw by the date ligand, and after that, mirror it. Let's go. Okay, done, guys. Okay, please check, draw your mirror image, and that's it. It's not difficult also. You've done it during AS. It's basically the same thing again. Let's go. All right, guys, done. If done, next page, please. Jump. There. So far, so good. Hannah, not hard, right? Okay, the last one is the hardest. This, right? Ayo, it's not in the syllabus, right? Then suddenly just pop out exam, and they just expect you to know it. They really expect you guys to somehow can tell the difference. So some of the questions that I really cannot predict. Yeah. The moment I saw this question, I'm like, oh my god, this thingy actually come out. So this thingy, right, is quite special. It's when they combine cis trans and optical together. Okay, so there's no proper naming for it. I call it as a cis trans optical, but that is not the official name. I don't even know what it's called. Yeah, so it's just isomer with no names. Yeah, so I call it as a cis trans optical because it's everything all together. Okay, so guys, cis trans optical, hi, it's only possible. Again, I'm gonna give you the hack. The hack is very simple. Once you see a central metal ion with two bidentate and two monodentate, okay, then you need to watch out already. Okay, two bidentate and two monodentate. Then you have three isomer, cis, trans, and an optical ion. Okay, so again, it's never in the syllabus. I never taught your senior before. 3 years ago, it's not even in my notes. Then suddenly it pop out in the exam. Then oops, now you guys need to know it already. Okay, so guys, again, so you just have to imagine, right, guys, NH3 is our monodentate. En is a bidentate. By the way, En is a bidentate. Okay, En is a bidentate ligand. All right, guys. Again, I want you guys to draw trans first. Let's draw trans. All right, guys, think about it. What did I mention about trans? Trans is when your similar ligands are 180 degrees apart. Okay, a good one, you can always start with NH3. Kid, I'm gonna give you the first NH3. Okay, I'm just gonna show you, okay, show the first position of NH3. You guys complete the next. Go, try. Okay, try first. Draw a trans for me. I want you guys to draw a trans. At least you know how it look like. Okay, go. Meanwhile, let me order my dinner. Ha, ha. All right, guys, NH3 here. Another one is gonna be NH3 here, right? Okay, then your EN, guys, you can draw something like that. Wee. Okay, so that's how you draw a bidentate. You just draw a big EN. Okay, that surround two bond and done. Okay. Alright, then guys, I have a question. First, is there any optical isomer for this compound? Can you mirror this? No, right? Guys, if you put a mirror, yeah, when you try to put a mirror, do you see that it's basically what? The same thing, right? You can see. Oh my god. Yeah. So basically, it's the same thing. You can see that. So guys, for a trans, I want you guys to put a remark here. Is there any optical present? No optical. Or you can mention no optical or no mirror image, right? I have another question, guys. Is this structure polar or non-polar? Again, try to visualize the shape. Polar or non-polar? Non-polar. Well done. Just imagine you're in the center, being put on top, below, same force. To the left, to the right, same force. So everything gets cancelled out. It's non-polar. Try to visualize the shape, yeah? Okay, so trans is a non-polar arrangement. Okay? Okay, guys. Now, what I want you guys to do is to give me a cis. The same thing. I'm going to start with NH3 here. Complete everything. Give me a cis now. Alright, guys. I'll draw. I can draw it here. Ding, ding, ding. Do you see it's 90 degrees apart? Alright, guys. You can either draw it here or you can draw it here. I don't mind. Okay, so you can draw it this way or this way. Okay, then your EN, it's like that. Right. Alright, guys. This is a cis. Is that right? Okay, let's look at your cis. Okay, your diagram and mine might not be the same. So let's say if you get NH3 here, then you rotate this way and this way, it's okay. Okay, don't change it. Keep it. Okay, don't just copy my answer. Alright, guys, cis. Okay, and I have another question. Is this polar or non-polar? Polar or non-polar? Polar. Polar, yeah, guys. Why? Ding, 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 ding. Pull here, you fly this way, right? You see that? Good. Okay, guys, now, what I want you guys to do is to put a mirror in the middle and draw a mirror image here. Go. Draw a mirror. Mirror it. I got your answer already? Okay, let's go, guys. How does it look like? Okay, it's gonna be okay, NH gram. NH3, ding ding. NH3, ding ding. EN, ding ding. EN, ding ding. That's it. Okay, okay, guys, do you see that these two molecules, they are not the same? So again, you don't need to know the name, but I usually call it as cis optical. Okay, but that is not the proper name. So, but in exam, when we are doing the past here, I'll just tell you to draw a cis optical. This is what I'm referring to, a cis and an optical, Okay, you don't need to know the name. Again, don't need to know the name. You just have to know that there is an optical. Again, it's also a polar structure, right? Understand? Clear? And we are done with all the isomer already. Okay. So guys, now, sure, yes. What's up? I want to see top drawing, can. Okay, guys, now we have some time. I just want you guys to try next page. Let's draw it together. Okay, so draw for another 10 minutes, then we will conclude this chapter, then we can move back to our ionic equilibrium. Yeah. Okay, next page, this page, done. I'm gonna walk around and check all your diagram here. Start walking around now, please. For guys, again, if you're not so sure what to do, you can always check the general formula. Let me give you a hint. You see this is a monodentate, right? It's a monodentate 4, monodentate 2. You can refer back to your notes. Where's monodentate 4, monodentate 2? Can see monodentate 4, monodentate 2. Yes, so monodentate 4, 2 to show what kind of isomer. H4 must be 90 degree apart. Alright guys, the first one, okay, I still see some of you guys not getting it right, but it's okay. So guys, okay, this question is the easiest. First question you have to ask yourself, I don't care about all this question, don't care about the stereoisomer. Now, look at the general formula, monodentate 4, monodentate 2. Monodentate 4, 2 will show cis trans, correct? So guys, I just randomly draw, you go and do the ding, and the triangle, please, because I need to be quick. So again, start from your monodentate first. Monodentate has to be 180 degree apart, correct? Or monodentate 90 degree apart. Okay, can see that? Then remaining are just NH3, 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 NH3. Oh my god, oh my god, oh my god. Done. Okay, guys, again, 90 degree, 180 degree, 90 degree. Done, that's it. Just look for your 90 and 180 and done. Sweet, huh? Yes, correct. You can put anywhere. So some of you guys put H2O here. Okay. If you put it here, I'm okay. Okay. But don't do one H2O here, then another H2O here. Okay. Don't give me two 180. They are not. They are the same. Okay. Okay, guys, next. Let's go. Alright, kid. Very simple. Okay, where is my thingy? Okay, the complex stereoisomerism. Okay, highlight the word tree. Okay, this thingy show tree C2O4 2 minus to show three-dimensional of one complex ion. They just want you to show one. Basically, they are quite lenient already. So how to draw the first one? Very simple. This question, I'll just guide you guys how to do it because it's too easy already. Okay, guys, again, try to avoid, before you do it, right? Guys, do not do this, Don't do C2H4. Okay, so some of my kids will do this, guys. Don't go top and bottom like that, guys. I'm begging you guys, do not top and bottom it. Why? Guys, the reason why you don't top and bottom, right? Okay, in order for it to be top and bottom, so basically, right, the distance is too far away already. You can see that. Okay, top and bottom, or front, back, or left to right, right, the distance is very far. Okay, so but if it's 90 degree, the distance is very close. Okay, and the bidentate ligand cannot be stretching all the way from top to bottom. Understand? So do not do a top and bottom. Try not to. Okay, do a 90 degree, 90 degree, 90 degree. That's good enough already. Okay. So 90 degree, 90 degree, 90 degree, 90 degree, 90 degree, 90 degree. Done. That's it. Simple as that. Okay. Very easy, right? Okay, guys, can anyone tell me what type of isomerism it shows? What type of stereoisomer? Optical or cis trans? Optical, yeah. Okay. So this compound does show an optical isomerism. Okay. Okay, next. Go. We're gonna do some questions together, yeah. Thursday class is gonna be slow and practice. Okay, Friday class is we are doing organic. So organic, no time to practice. We're gonna rush through all the organic first before we start practicing. Alright, guys, next. What type of stereoisomerism it shows? Cis trans. Okay, so cis trans or geometrical are the same thing, yeah. The first one is easy, right, guys? Okay, so I just have to put my NH3 90-degree apart. Okay, or NH3 it's 180 and this is 90-degree apart. Remaining you just draw yourself, yeah. Okay, next one. This is also easy, right? Cl 180-degree apart, Cl 90-degree apart. Done. Okay. Easy 2 marks. And see guys, 180, 90, 180, 90. Okay, okay, next. Let me see. Is there any good question? No, this is okay. Repeated question. Not doing this. Not fun. Okay, yes, guys. Page 19, this question now. I need to ensure you guys do not lose any mark in this drawing because it's free mark for you guys. So guys, transition element, right? I already break it down into part by part, yeah. Okay, so try to practice all the question in the notes. Okay, it's not a very difficult chapter, but it's very confusing one. Do all the questions. You could turn back time. Done. All right, guys, the same thing, similar like a 180-degree apart. So this time I'm going to put it here. Okay, then the NH2, you fit it on your own. And H2, this time I'm going to do something different. I'm going to give you another arrangement that looks something like that. Also 90-degree, right? You can see that, yeah? Okay, again, guys, anywhere is fine. Okay, don't just copy my answer. Check yours. Okay, please show a different one. Try to draw a different one compared to mine. Okay, so again, 90-degree, 180-degree, 90-degree, done. Remaining, you do it yourself. Okay, guys, polarity 1. Is it polar or non-polar? Non-polar, right? Polarity 2? Polar, easy, Can visualize, right, guys? Again, just imagine you stand in the middle. Someone pull you left, someone pull you right. Stay stationary. Stand here, someone pull you this direction, you fly. Polar, okay? Easy? Okay, good. Next. Do I have the same? Okay. Guys, try this up. Number 6. Oh, okay. Question number 6. Let's go. All right, guys, this one done. Let's see, yeah. Health isomerism of the right. Clear. Sorry, my bad. I just realized I drew the same thing, right? Okay, Kenna. Thanks for reminding. Okay. Okay, guys, next page. This is one of the toughest question. One of the toughest. Okay, not 7. I don't want you guys to do 7. I want you guys to look at these. Very, very fun. Let's go. So, guys, you see, I have C2H2O22, C2O4, BrCl, exists as stereoisomer. Okay, 3-dimensional to show 4. Okay, so guys, let's do it now, yeah. Go. Okay, guys, try to think about it. You have to visualize the shape. I hope you can visualize the shape. Okay, so this really need your visualization in 3D. Alright, guys, before you do it, right, you have to understand what type of isomerism it shows. Anyone? Cis, trans, or optical? Cis, trans. Well done. So, guys, again, if you do not know what to do, you blur. Very simple, guys. What differentiates between the cis and the trans? 180-degree and a 90-degree. That's it. So, guys, no idea what to do? First one, very simple. H2 and H2O, put it 180-degree first. Guys, there's only one way, right? You can put your H2O to show it's a 180. Where? Top and bottom, right? There's only one way. Okay, top and bottom 180. That's the only one way. All right, guys, next. We're done with this. This one 180, right? Okay, I just put it like that. It's a line showing it's 180. Okay, next. Guys, CLBR. Okay, who hit? Okay, now, okay, you check your diagram. And I'm going to show you some answer. You guys going to tell me is it right or wrong, yeah? Okay, not necessarily is correct, yeah? I will just randomly put some answer. At least you need to know how to differentiate. Guys, I'm giving you the second option now. Okay, go. Same, different. Can it be your second answer? Someone say different, someone say same. Yes, so it's same or different. This is the trick already. Same or different. Same or different? Same, different. So someone say same. Someone say different. Good. So guys, the answer is not accepted. Why? Guys, these two, 180. ClH2O, 90. BrH2O, 90. ClBr, 90. Look at this. BrH2O, 90. ClH2O, 90. BrCl, 90. It's the same thing. Guys, again, don't memorize the shape. Memorizing doesn't work, yeah, because you might have question like that, then GG already. So please remember, the only thing is the bond angle. Look at the bond angle. So tak boleh. Cannot like that. Okay, guys, now, any other way that you can draw it? So, guys, we're going to draw ClBr 180 this time. Okay, let's go. ClBr 180 this time. And H2O, H2O. Okay, so guys, is this same or different? It's different, right? Definitely different. Okay, next. Guys, now BrCl H2O, H2O. Same, don't. Okay, guys, again, 180 is still your Cl and Br, right? Correct. Okay, very simple. You just look at your 180, done. Hit, done. How you should do it? You see, guys, if you have this, right, it's basically like a game. You just try and connect them in a straight line. Connect them straight line. Connect them straight line. Where else you can connect them to give it a straight line? Well, but what about these two to give a straight line? Also can, right? All right, go. H2O Br. Okay? And see that? Do you see H2O Br? Then the remaining two, you can just anyhow put it. It doesn't make a difference anyway. And see that? Okay? So guys, very simple. 180 and 90 degree, you can get the answer done already. Don't memorize the shape. Alright guys, next I'm going to show you another structure. Please tell me, is it the same or is it different? I think you guys are already quite good at it. I cannot trick you guys anymore. Sad. Same, you guys already, yeah, see, you guys can tell already. Good. I like it. Okay, you should be able to tell. Okay, so it's the same thing. Don't get tricked. So trust me, some of your friends will draw it. They will draw it this way. If I never tell you the bond angle, you will draw this, then you assume it's right. Okay, so guys, sorry, it's the same thing. Tak boleh. Okay, guys, you see the fourth one. Where's the fourth one? You see Cl and H2O 180 degree, right? So guys, if you have this thingy, right, then you see that it's 4 isomer. 4 isomer. 1, 2, 3, 4. Okay, just look at the 180, you get the answer already. Okay, so H2O here, Cl here, and BrH2O. Yes, okay, correct. So guys, again, in your mark scheme, you might encounter this. Okay, so if your mark scheme, you read the answer like that, then you go and mark yourself wrong. Basically, they are the same thing, right? Why? ClH2O, 180, you can see that. H2O, H2O, 90, you can see that. ClBr, 90, you can see that. So guys, they are the same thing. Don't get tricked. Please, this is one of the tricky questions. But if you look at the bond angle, 180 and 90 shouldn't be a problem. Okay? All good, yeah? The oxidation state is fine. Oh, okay. You want to try? Yeah. Maybe we can try this. Let's try the last one. Okay, the last one, please. Okay, I hope you guys are already a master at it. Please, I hope everyone get it right. Okay, so guys, L represent monodentate. Okay, so what is NO? NO is also a monodentate. So basically, you have L2Cl3. L2Cl3. Oh, sorry, you still have one more L and three more Cl. Let's go. So you have L, Cl, Cl. 1, 2, 3, 4, 4, 4, 4. My bad. Well, go. So they are pretty nice to you already. They already put the NO for you. They already fixed the position of NO. Okay. Alright, guys. You are done. You guys are done. Okay, I'm gonna draw three random one. My answer not necessarily correct. You guys gonna pinpoint which one is correct, which one is wrong. Okay, that is more fun. I give you the correct answer, then you just copy anyway. Tak boleh. Not fun. Wow, very fun. Alright, guys, go find my mistake. Yeah, I think you guys learn better from spotting my mistake. So I'm gonna call it as A, B, C. Yeah. Go and find which one is wrong. Which two are the same? A and C. I think you guys can see A and C are the same, right? Well, thank you very much. Good. A and C is definitely the same. Guys, why? B is definitely different. Yeah. Why? L is already 180. Okay, so guys, if you cannot see it, I highlight it for you guys. And see, there's no way you can find A and C with L 180. Correct. Okay, guys, why A and C are the same? Cl are both in 90, 90, 90, right? Can see that? Cl90, Cl90, Cl90. Easy. So you have to swap one of them to 180, right? So guys, you know how to draw it to 180? Very simple, right? So L, I pick anywhere. Nah, cannot. Must be here. Hey, sorry. Alamak. Must be here. Okay. So LL, put it 90 degree and leave one space for your Cl. Can see right now you have a Cl at 180 degree already. Yes, correct, right? Understand? Okay, please, guys, you just have to identify the bond angle. There's no way you can get a 180. Okay, provided you can visualize this shape. If you cannot visualize this shape, hard this to sleep. Yeah. Okay. So stereoisomer, cis trans, geometrical, done. All good. Okay. So guys, we are done. This is one of the toughest question. Yeah. Okay, so if you can do it right, then none of the question can trick you. You just have to find the bond angle. That's as simple as that. 90 and 180, 90 and 180, done. Okay, so this part is over. The remaining part, we are also done with it already. Easy. Not doing it. What is this done? This is done. Hiya. Okay, yeah. So guys, we only have 12 more minutes. Insane. Wait, let me see for chapter 20. Please like and subscribe. Someone can take it. Please like and subscribe.